Tonight is section 3.1, Extreme Value Theorem. This will be part 2. I want to begin by a question from last night's homework. This is the question that we did not address in class. It happens to be number 8. Number 8, it's the function f of x equals 4 minus the absolute value of x. It said find the value of the derivative, if it exists, at each indicated extrema. Those were the directions. And so, again, just as a reminder, parent function is absolute value of x. It's been reflected over the x-axis and has been vertically shifted up 4 units. So on the picture that you had in your textbook is something to this extent. And this is where we already know that as at x equals 0, that it has an extrema, but they just want us to verify it mathematically, except at this point we don't know how to take the derivative of the absolute value of x. So what we're going to have to do in order to check, even though we know it is a critical number, is we're going to have to use the limit definition of a derivative. So f of x, the derivative f of x, equals the limit as x approaches 0. And I'm going to use this generic equation. I'm going to use this one here. I already put it in 0. It usually says a here. So for our function, the limit as x approaches 0, again I want to see it at 0, and it should be undefined. We shouldn't have a slope that's equal to 0. That should not be the slope of this at 0. It should be undefined because it's a sharp turn. So let's put in the original function minus, substitute in 0 for x, all over x minus 0. Let's clean that up. I still need the limit. I've not taken the limit yet. So what is that? That is 4 minus absolute value of x minus 4, and that's just a 0 all over x. I think I can clean that up one more time. 4 and a negative 4 go away, so negative absolute value of x over x. And again, we have to remember what this graph looks like. We have to see the graph. This is a graph of the derivative. Let's see if we're able to take that derivative. It's supposed to be undefined. Let's see if we can remember why it's undefined. Well, I'm not allowed to use 0. It's been reflected, so it's at 1 and negative 1. I'm sorry, 1 and negative 1. And it's the graph of the absolute value you just need to know, and it looks like this. So when I take the limit of an absolute value function, you have to go at it from the right and from the left. And the two must be the same for the limit to exist. So as I approach this function here, approach 0 from the left, I get negative 1. As I approach this function, to 0 from the right, it's equal to 1. These two sides do not match, so the limit does not exist. So the derivative of this does not exist. So we have verified, as we were supposed to, from the picture, that this is a critical value. In other words, find the value of the derivative if it exists. Well, it doesn't at each indicated extrema. Well, it doesn't exist. And we already know from later problems that that means it's a critical number. Now I'm going to start with tonight's notes. First off, let's start with the homework. The homework for this new piece is still 3.1, but it's 19 through 33 and the odds, which means you have all the homework. So let's go over again the extreme value theorem. here's what it states. If f is continuous on the closed interval, it's not open, it's closed, you actually use the endpoints, closed interval a and b, then we are guaranteed an absolute max and an absolute minimum, which are called our extremas. So by the extreme value theorem, if f is continuous within this interval, which means I pick up my pin, I do not pick up my pin anywhere between the values a and b on my x-axis, then we are guaranteed an absolute max and we are guaranteed an absolute min. And that's a y output on the original function. All right, so then my next question would be, how do I find these? How do I find these guaranteed absolute max and absolute mins? Well, we test for our critical numbers. Well, we test our critical numbers. Well, I gotta remember how to find critical numbers. Critical numbers is by taking the first derivative, setting it equal to 0, finding out what x values coincide with, on the original graph, has a slope of 0. In other words, our relative mins and our relative maxes. And b, when I take the first derivative, where is it undefined? Maybe it's that cusp or that sharp corner. For here, it's our relative max and min at what x value? So my x-axis, what x value? For here, what x value do I have that cusp? That's my critical numbers, my x values. Let me write that down for you. Now, after I find those, then I substitute the critical numbers into the original function, f of x. And then I write my ordered pair. Critical number, comma, my f of x, my y. Okay, so now I know what's going on in between my interval, but it could possibly be, I don't know, let's say at this closed interval, there's my a and there's my b. So I'm going to start out and, maybe it does this. Okay, so from test number 1, from part A, I would find out this critical value, this critical value, this critical value. I would substitute them back into the original function to get my y. And I would find out, so far, this might be my absolute max. It's going to be the highest y value. Here's my y-axis. That this is going to be low, and this one's not quite as high. Maybe this is my absolute min, because again, I don't have a picture. But the next thing I need to do is I need to test the endpoints, which are my a and b, at a and b. What am I testing for? To see what that y value is. Plug it into the original equation. So let's see. That would be this one. Oh, that's much lower. And let's see, right here at the end. So my absolute max in this picture is here, and my absolute min is here, and that comes from the n value. So test the endpoints a and b. In other words, substitute them back into the original equation and see what y I get on both of them. I have to test those. And so out of all of these tests, what y's from here and from here, what y's are the lowest? Absolute min. What y is the biggest number? My absolute max. So I'll just try to say that here. The highest, largest y value from step 2 and 3 is the absolute max. The lowest or smallest y value from step 2 and 3 is the absolute min. It's my lowest value. Oh, I'm not showing you my notes. I just realized that. I apologize. I will pause for a moment so you can take those notes down. What I'm going to do next is I'm going to proceed to do a couple of problems. I'm going to go ahead and move on now. I would like to do, my first problem will be number 24. So you can see it's an even problem around your homework. So I have an equation here, a function, and I have a closed interval, and I'm supposed to find the absolute min and absolute max. In other words, my extrema, my absolute extrema. Let's go find those. Let's see, what does step 1 say to do? Check for our critical numbers. Well, no, actually I need to take the derivative first. That would help. Let's take the derivative. 3x squared minus 12. Done. For our critical values, that means where is my slope equal to 0? Okay, I'm going to test for that now. Let's go do that. So I substituted f prime of x for 0, slope of 0. I am going to go ahead and try to do some factoring here. We can factor out the 3 times x squared minus 4. That is a difference of square. So that means I have, let's see, x minus 2. That means x is a 2. And x equals a negative 2. So those are my two first critical values. Let's go ahead right now and let's substitute those into the original equation to see if it, what kind of y values I get. So I'm going to substitute in 2. That's 2 cubed minus 12 times 3. That's 8 minus 36. Oops, I'm supposed to put in a 2. Sorry. 24. 8 minus 24. Apologize for that. 8 minus 24, that's a negative 16. So that order pair is 2, negative 16. So that could be an absolute min. I don't know that yet. I'm going to put in my negative 2. So that's now negative 2 quantity cubed minus 12 times a negative 2. Negative 2 quantity cubed is a negative 8. Negative 12 times negative 2 is a positive 24. Positive 24 and a negative 8 is my 16. So that ordered pair is negative 2, 16. Ooh, that could be an absolute max. So again, back to my steps. It says to find all the critical numbers. Critical numbers is by setting this equal to 0 or to see if there's any place that my derivative can go undefined. Well, with that derivative, there's nowhere that's going to go undefined. I can put in any x value I want, and I'll never get a denominator of 0. Okay, I'm done looking for critical numbers. The next thing that I'm supposed to do, in fact, let me put these steps back here. I've done the critical and I've substituted. Now I'm looking at endpoints and I'm going to substitute those in. And then I will find out my extrema, my absolute extrema from there. Put a line. So now I'm going to test my endpoints. My endpoints. One is 0. So 0 cubed minus 12 times 0, that's 0. I get the order pair 0, 0. Well, that is not an absolute max or min yet comparatively. Let's put in my other endpoint. That's 4 cubed minus 12 times 4. So 4 times 4 times 4 is a 64, and a negative 12 times 4 is minus 48. So what is that? That will be a 16. What order pair do I get? 4, 16. Here I go with my conclusion because I'm done. I've looked for all the extrema that I can. So the absolute extrema is 16 and negative 16. The absolute max is 16 with the order pair being 4, 16 and negative 2, 16. the absolute min is negative 16, with that order pair being 2, negative 16. Done. I'm done with that problem. Next problem. I will do one more problem because I'm already 15 and a half minutes into this video. Let's try, gosh, do I want to do that one? Yeah, I'm going to choose a difficult one now, number 26. It says f of x equals the cube root of x between negative 1, and 1. So first thing I'm going to do is actually rewrite this before I take the derivative. We learned that technique a long time ago. Now I'm going to take the first derivative and bring down the 1/3, decrease that by 1 power. I'm going to go ahead and rewrite that derivative. That's 1 over 3, let's see, it's a cube root with an x squared. Okay, so the first thing I'm going to look for in my critical numbers is to see where the slope, what x value makes the slope 0. So I'm going to have my slope of my tangent line be 0, and I want to find out which x values that would be at. So I'm going to solve for x. Well, I'm going to write this down. This looks a little awkward, but it kind of looks like I can make each of those a fraction, and I can cross multiply. So this times 0 is 0, 1 times 1 is 1. Well, that absolutely makes no sense. 0 does never equal 1, so I get none from here, no critical values. I'm going to put a little line to show I'm going to go on to the next one. Now I'm going to see if I can figure out where that derivative is going to go undefined. In other words, where am I going to get, what x value will give me a denominator of 0? So let me go back and grab that first derivative again, because that's what I have to study. And I have to figure out where this is going to go undefined, what x value. In other words, I need it to look like this. That's undefined. What x value would make that happen? Oh, 0 would. When x equals 0, well, let's see, that'll be 1 and a 3 and a cube root of 0 squared, but that anything, that would be 0. So what I get out of this is my x value equaling 0, my slope becomes undefined. So now let's go and let's substitute that in to what my original equation. Let's see what point on my original function this happens at. Okay, I'm going to put in 0 for x. That happens to be 0, so I get the point 0, 0. That's the first point I have. I don't know if that could be an absolute max or an absolute min in my extrema. When I'm done with the critical numbers, I've done both of those criteria. Only thing I have left now are my endpoints. Okay, put a little line. I'm going to check endpoints. And that's -1 and a 1. So let's do f of 1. The cube root of 1, that's 1. I get the order pair 1, 1. I'm going to test -1. Cube root of -1 happens to be a -1. I get the order pair -1, -1. I have 3 points. I have nothing else to do. So the absolute extrema is, let's see, what's the smallest value? -1, and what's the largest? And 1, sorry. The absolute max is 1. The absolute min is -1, and I'll go ahead and just write the ordered pair here. And I'm done. I'm up to 19 minutes on this video. I'd really like to do one more problem, but I would think I will save it for class tomorrow. Have a good evening.